Hello everyone, welcome to DevOps Info channel. Today we are going to take a look at the conceptual understanding of the large language models. So this video helps and gives information on the high level understanding and gain conceptual knowledge of how they work in the backend. So all these Gen AI applications are powered by language models, which are specialized type of machine learning that you can use to perform the natural language processing tasks. So this NLP is an interdisciplinary field that combines computer science, artificial intelligence, and linguistics together. So by combining these three things, it is able to do first the speech recognition. It's like converting a spoken language into text classification, categorizing the text into predefined classes or labels, and natural language understanding, which is extracting the meaning and context from the text. And last, it gives the natural language generation, which is creating a human like text or responses. We have also talked a little bit about this in the previous video of the OpenAI. I highly recommend to take a look at it. So, this Gen AI applications are the large language models. These are machine learning that uses natural language processing. These LLMs are there in the market for quite a long time. Like they are mainly based on the transformer architecture. So this transformer architecture are trained with large volumes of text and trained between words and sequences. So basically this transformer model consists of two components like what you see in the screen. Like they consist of encoder and they consist of decoder block. So the encoder block is a semantic representation of a training or a vocabulary. And the decoder block generates a new language sequences. Like first, these models are trained with a large volume of natural language text often sourced from the internet. Like for instance, when you talk about the OpenAI, it uses the internet until and unless you customize it, sanitize your own data, and create your own internal source for data. Like for example, when you create the OpenAI service, you have three options. Like you can fetch it directly from the internet, or make the service accessible only to specific endpoints, or you can make it as private endpoint. So it all depends on how your data is, what data your language model is trained. So basically, these texts are broken down into tokens. Like in this encoder block, these texts are broken down into tokens. We'll talk about the tokens in the upcoming slides. So these tokens are nothing but the individual words. So the encoder block processes these token sequences and then they give a token ID. So this technique is called as attention to determine the relationship between the tokens. We'll also talk about attention in the upcoming slides. So based on this attention token and the token IDs, it tries to match these tokens that are used in the same context. Like the output of this encoder is basically a collection of these vectors. Like for example, when you talk about the tokens, you have the first three categories like dog, cat, and puppy. They all belong to one category, which is animal. And the next one is the skateboard. Yeah, it's completely different. So the attention technique usually tries to match the similarity between the tokens and tries to predict the next sequential output. So this is how it works. So the implementant, again, the implementation of the architecture varies based on the model you use. Like for example, when you talk about Google, they use something called BERT, like where it uses two encoders, two versions of encoder. And when you talk about ChatGPT, they use only decoder. So for example, in this case, like the input sequence, like there is like when my dog was, and the model can use the attention to analyze the input tokens, and it would be able to complete the sentence puppy. So that is closely relating to the request what it is coming in. So this is how the transformer model works. Basically it has encoder, decoder, and encoder has multiple tokens, and the token is given a token ID, and based on the attention technique, it tries to matches the next version of the text that the user is asking from the input. So let's go to the next slide. This is about the transformer, and let's talk about the tokenization. Because what are the tokens and why we need tokens? Because tokens serve as the fundamental building blocks that allow the large language model to process and understand the text. Like when dealing with text data, large language models convert a raw text into a sequence of tokens. So these tokens can be words, subwords, character tokens, or special tokens. So why this tokenization matters is because tokenization enables these large language models to analyze and generate language in a structured manner. Like it captures uh, any mistakes in the grammar, syntax, and then it allows the model to understand and generate the correct version of the text. Like word tokens, like when you talk about the word tokens, like you see it on the top, you have it here. So in the word tokens, it represents a complete words in the text. For example, it's over 9,000. It has three tokens, like it's over and 9,000. Even in the subword tokens, this can be parts of the words, such as subword units or character fragments. So this subword tokenization allows the large language models to handle vocabulary words and capture the fine grained uh, words from it. Like for instance, the word unhappiness might be split into subword tokens unhappiness. Like you see what you hear, like what is split from a single word. And the character tokens can have the individual letters. And the last one is called the special tokens. These include like markers like CLS. For example, CLS is used for classification tasks, and SCP is used for separating the sentences or segments. So this helps to structure the input for the large language model so that the large language model will be able to help further. So in the tokenization steps, you see the tokenizer breaks down the input text into smaller pieces, chunks, creating the tokens. And these tokens represent the meaningful units for the processing. And then these tokens are given the token IDs. Each token is assigned an integer. Like for example, the word cat, it can have token ID 15, and then that will be helpful during the process, during the transformation. And this again, this tokens are used in the encoding and decoding, because replacing the textual tokens with the numeric IDs is done in the encoding. Because if you go back to the previous slide, you have the encoder. So in the encoder, what it happens, like all the textual tokens like dog, cat is replaced with the token IDs. This is called encoding. And while converting the encoded tokens back into text, this is called decoding. So basically in the encoder, it has the token as a words that is given as a token IDs, and in the decoder, when coming back, it is given back as a text. So this is what is explained in this example. So the tokens have the token IDs. So during this, the large language model tries to do the vocabulary building and tries to give the output. So this tokenization is the very important step in the large language model. Going next, we'll talk about the embeddings. So the embedding is the next process that happens after the token gets the token IDs, because from the numeric IDs they go to the embedding. So these embeddings are the token representation. So the token words, subwords are represented as embeddings. So these embeddings capture the semantic information about the tokens. Like what is the semantic information? For example, I go to this dog, it will have the information about the dog. For example, how tall the dog is, like how much weight the dog is the dog a puppy or it's an adult. So all this kind of information, the semantic information, will that's embedding will be having all the semantic information about that particular token is called as the embedding. So these embedding provide more information and meaning to the large language model, because it's not only a dog, it has more information about the dog, about its height, weight, it's is it a puppy or it's an adult. So all this information is mentioned in the semantic information. So the next part is the vector space. So the vector space is like a multi-dimensional. If you see here, these are the multi-dimensional vector space. So each dimension represents a specific semantic attribute. Like for example, if you talk about in the vector space, you see the dog, the puppy, and the cat. They are in the same direction because they all belong to one category, which is animal. And if you talk about the skateboard, this skateboard is completely on a different direction because it's a sport equipment which is in a different direction because of its characteristics. So what the large language model does is like it will try to find the similarity. It will try to match between the vectors. Like for example, we have a dog and a puppy. It will try to match the direction of similarity, and then it would able to match the next sequence. So this vector is also a very important part because the vector representation will coherent and it will align it will basically align the multidimensional vector space because this will align the embeddings in the direction of the relationship. For example, in this case it's animals, and then this will help the language model to understand the next sequence based on the direction where it is flowing. So basically this is about the embedding. And next, when you're talking about the embedding, and this embedding utilize something called the neural network architecture. So this neural network architecture is composed of the interconnected nodes. So with this neural network training, they train the model and predict the context of each word with a specific window of words. Like for instance, if adorable is the target word, the context might look like are adorable. And the neural network will fine tune the word vectors during the training, and it predicts the accuracy. So it will search this within a context of words. Like for example, in this adorable, it has different words are adorable, and it will try to find the next sequence of the word which is matching. So basically, the neural network will fine tune the word vectors during the training to enhance its predictive accuracy. In summary, the neural networks within the large language model process and transform the input data, enabling them to generate coherent, contextually relevant languages. So, uh, basically, the fully connected neural network will use this training and adjusting weights, and also it will use the inferencing techniques. So, this is mainly about the attention. This is mainly about the embedding. And the next, we are going to talk about the attention. So in the attention mechanism is the NLP that allows models to focus on a specific parts of an input with generating each element of the output sequence. So there are multiple options. You see here, there is a word embeddings, you have the RNN based models, you have the LSIM based models. So this RNN is nothing this is like recurrent neural networks. So this is a neural network architecture within the hidden state that uses the feedback loop to process the sequence of data. And the same thing is about the learned simulation metric. It's a metric which is designed to compute the distance values from numerical simulations. But here we're going to talk about the attention. So the attention is a natural NLP task that allows model to focus on specific parts of an input sequence when generating each element of the output sequence. So this attention mechanism mainly was introduced to improve the performance of the encoder and the decoder models, especially for a task like machine translation. So this will do the alignment scores. So these scores indicate how well the input elements align with the current output positions. Like they are computed using function that takes encoded hidden states from the previous decoder output. So, and also they do the weighting mechanism. Like the alignment scores are transformed into weight using a different softmax operations. So this weight determines the relevance of each input vector. And the last one, they have the context vector. The context vector is a unique context vector that is a sum of all encoder states. So basically, it has the alignment scores, the weight, and the context vector. And the main reason for the attention is to improvement in the encoder decoder models. So basically, alignment scores, weight, and context vector. is the process that is used in the attention technique, and you don't need to look more into this part. This is the high level. So these are the types, and we are talking only about the attention. And as I said, yeah, the recurrent neural networks uses the feedback loops to process the sequence of data, and the learned simulation metrics is a metric that is designed to compute the distance values from numerical simulations. So there are multiple ways, but here, if you talk about, for example, chat gpt, it uses attention. And next, having talked about it, you can use the language models. There are a lot of language models which is already available in the internet, or you can build your own existing foundation. But if you want to build your own existing foundation, it is going to take a lot of time and investment on the developers to build own language model and have your own data. But if you want to use the existing foundation model, for example, if you go to the model catalog in the Azure, the Microsoft Azure, if you go into the Azure OpenAI service, you can use the generative pre-trained transformer, which is the Chat GPT versions. You can use that, or in the model catalog, they have also partnered with other third parties like Hugging Face, Mistral, Meta, and others. You can use any one of them, and then later, you'll be able to further fine tune and then understand which is the best model that would help you for your use case. But like in general, first you need to understand which is the best model that is going to choose based on your requirement, and the most important part is you need to understand how are you going to fetch the data. It is going to be from the internet, then you have to do all your compliance work, or if that is not suitable in your case, then you have to sanitize, and then you have to keep your own data first. And going further, in summary, the large language models offer several benefits in the field of the natural language processing. Like, these LLMs are pre-trained on vast amount of data, usually from the internet, allowing them to understand and generate language across diverse topics and styles. In summary, like for example, all these AI products have common config, which is the vector database, and they use encoding concept to use a concept called embedding. So what is embedding? Like I have given an example in summary, like in the transformer, based on the encoder. Like for example, a user is asking some question about orange, like what is the color is of orange. The vector database would have the information in the encoder as tokens, and then it will have them in the IDs, and it will have the you know uh, vector database with the mappings. For example, if the user is asking question, what is the color is in orange, then it would have the vector database. The value is fruit. The value is one. So then it does the tokenization, and then based on the embedding and attention technique, it would be able to return the value. And for example, if the user is asking something about the orange color, is it a bright? Then it has the information in the in the embedding, and then it is in the token ID. It has the particular number and values. It would be able to pick that, and then based on the vector dimensional, it would be able to array. It will be able to take the next sequential output and give the appropriate answer. The same thing, like for example, if Orange is a company, then it would be able to find out the particular revenue, um, and then it would be able to give the output based on the numerical representation of the data which is present in the vector. So in overall, they are more versatile large language models. They can handle a wide range of tasks like translation, summarization, using the chatbots. So they excel at the answering the questions, summarizing the context, and producing high quality language. So LLM holds immense promise for enhancing communication, understanding, and accessibility of the information. But provided you have to train them, and you need to train them with the right amount of data, that would really help in utilizing your business case and increasing the productivity. That's all I wanted to give an information on the LLM. I'm still trying to find one use case of making work the open AI for one of the business case that might be helpful for any one of us. Um, hopefully I would be able to bring some demo on that, and hope you enjoyed this video, and thank you.